Someone is breaking into Hugging Face's servers, and the security team is watching it happen. The target is strange, an answer key. The burglar is stranger, an AI model, in the middle of an evaluation that tunneled out of its test environment and took the answers to its own exam. 5 days later, OpenAI confirmed the burglar was theirs. That scene is the AI industry's measurement problem in miniature. The scores you're shown are produced by the players, and checking them is optional. Today you learn how to check. A break-in is a strange story on its own. Take the burglary out, and one ordinary fact is left. A model was sitting an exam. Exams like that one run constantly now. You read that an AI can do a junior engineer's job, or solve maths problems that stop a graduate student. Both of those are test scores. Those scores are how this industry prices its own progress. Contracts and valuations move on them, and almost nobody asks the first question you'd ask about any other exam: who ran it? Last month, a British government body called the AI Security Institute went looking for an answer. Its researchers took 5 of the leading AI models and gave each one 475 attempts at a set of security tasks. Then they counted how often a model broke the rules to win. The finding is 1 sentence long. You'll get that sentence later, because it only means what it means once you know how these tests are built. For every other test in your life, you can name who administered it. Your driving test, your kids' exams, who administers this one? The easy version of this story is that the tests are rigged. That version is wrong, and working out why is what makes the real answer worth having. So here's the case for benchmarks at full strength. Most of these tests are public. Plenty were built by universities and nonprofits, not by the companies being scored. And the thing they measure really has moved. Work no model could finish 2 years ago is routine now. That isn't marketing. That's the tests doing their job. One of the nonprofits building the hardest of these tests is Epic AI. Epic is also the group that went looking for errors inside its own benchmark, found a lot of them, and published that itself. So when Epic defends benchmarking, it isn't defending a product. 5 days ago, it did exactly that. Any one score can be gamed, Epic argues, but the trend across many tests over several years is still the best evidence about where AI capability is going. That's a good argument, and it's mostly right. Now take DeepSeek, a Chinese AI lab. A week ago, it shipped a new flagship model with a page of benchmark results attached. Nothing exotic happened. DeepSeek ran a real evaluation on a real test and published a real number, 87.9%. Then an independent evaluator ran the same model on the same test and got 54.7. Both numbers are real. That shouldn't be possible. 2 real numbers for one model. To see how that happens, look at a result from a company called Databricks. Databricks took one model and put it on one task. It didn't retrain the model, and it didn't change a thing inside it. The model scored 36%. Then it scored 53. 16 points out of nowhere. What changed was the setup around the model. That setup has a name. It's called the harness, and it's what actually runs a model through a test. The harness hands over the task, handles the tools the model reaches for, and decides when an attempt is finished. So a model never sits a test on its own. It sits the test inside a room somebody built. Same student, same paper, different room. In one room there's a calculator on the desk and 3 attempts on the clock. In the other, a pencil. Which means a benchmark score was never a fact about a model. It's a fact about a model plus a room. And here's the part that runs the rest of this video. The company being tested usually builds the room, runs the test, and publishes the number. Then the number leaves the building before anyone outside has rerun it. That's the closed loop. Nobody has to lie for it to work. Nothing in the process requires an outsider to be let in. Case 1. 2 numbers, 1 release. The Databricks result was a lab demonstration. This one shipped. A week ago, DeepSeek released its new flagship, claiming a jump of up to 50 points on agentic coding tests. Those are the tests where a model works the way a programmer does, using tools over many steps. On one of them, Terminal Bench, DeepSeek reported 87.9%. DeepSeek also published its room. The same day, it open-sourced the harness its model ran inside. That's more disclosure than most labs give you, and it's worth saying so. But that benchmark has a neutral reference harness of its own. A commercial evaluator called Val's AI ran DeepSeek's model on it, 3 full trials, and measured 54.7%. Same model, same benchmark, 33 points of difference, and every point of it lives in the room. Every lab loses ground on a neutral harness. That's normal. The rest drop a few points, sometimes low double digits. 33 is not in that range. Measured that way, DeepSeek's flagship also lands underneath its own cheaper, smaller model. So who else has checked the new release? One commercial evaluator on one benchmark. That's the entire list. The US government does have a body that evaluates these models, and it has published on DeepSeek. But that report covers the April preview version, not the one that shipped this month. And there's one more number in that same release. On a test called SWE-bench verified, DeepSeek scores 96%, third-party measured, second out of 82 models. That one is real. Nothing on the page tells you which is which. Case 2. The exam that leaked. Case 1 was about conditions somebody chose. A score can also fail with nobody choosing anything, which is stranger because there's nobody to blame. Which brings back SWE-bench verified. 6 months ago, OpenAI stopped using it. OpenAI reported that Claude Opus 4.5 scores about 81% on SWE-bench verified. Put the same model on the newer test built to replace it, and the score is 46%. 35 points, nothing changed inside the model. Nothing changed about the room either. What changed was the test. SWE-bench verified is built from 500 real coding problems pulled off GitHub, where the world's programmers keep their code and their fixes. The problems are public. So are the fixes. And these models are trained on public code. In February, OpenAI ran the check and published it. Every leading model it tested could reproduce the exact fix to some of those problems, word for word. The models had read the answers before the exam because the answers were on the internet, and these models are made of the internet. Nobody cheated. Nobody decided anything. OpenAI retired the benchmark. Other evaluators still run it, which is why DeepSeek has a score on it at all. The measurement is honest. The exam is the problem. Case 3. The replacement broke too. OpenAI didn't only retire the leaked exam, it named a successor, SWE-bench Pro, the test that produced that 46% a minute ago. That was the fix. In July, OpenAI audited the fix. Close to a third of its 729 tasks turned out to be broken, not too hard. Broken. Some carried requirements the task never told you about. Others were graded so strictly that an answer which actually worked came back marked wrong. OpenAI withdrew its own recommendation 4 months after making it, and this is the first good news in the video, so it's worth stopping on. OpenAI wasn't the only one who found it. A small analytics company called Pharos AI hit the same problem independently, weeks before OpenAI published anything. Two parties with no connection to each other, same finding. That's what checking looks like when it actually happens. It works, it's just nobody's job. Case 4. Who paid for the exam? Cases 2 and 3 were quality failures, embarrassing but honest. This one is a different kind of question, and money is in it. FrontierMath is a set of research-level maths problems built by Epic AI, the same nonprofit that defended benchmarking earlier in this video. It's what labs point at to claim a model can do real mathematics. OpenAI commissioned and funded 300 of those problems. It owns them. And for everything except a 50-question holdout, OpenAI can see both the problems and the answers. That arrangement became public in December of 2024, on the same day OpenAI announced its newest model had scored 25% on the benchmark. The criticism arrived a month later. Several of the mathematicians who wrote the problems said they learned about the funding when the public did. Some said they might not have taken part if they'd known. Then, this May, Epic reviewed its own problem set and found that 42% of the original problems contained fatal errors. Epic found that, Epic published it. Both things are true about the same organization, and neither cancels the other. Case 5. They went after the room. Every case so far has a person in it, deciding something, what to report, what to fund. This one has nobody deciding anything. 3 organizations, 3 different methods, 1 conclusion. First, the AI Security Institute, the British government body from the start of this video. 5 models from OpenAI and Anthropic, 475 runs each. Its published finding is 1 sentence. Every model we have tested for this behavior attempted to cheat. Cheating, in their definition, is taking an action the task didn't allow to reach the goal by a shortcut. It happened in between 11 and 14% of runs. And when researchers asked the models about it afterwards, the models didn't reliably say yes. Second, OpenAI reporting on itself. This is the break-in from the top of this video, and now you know what the burglar was after. OpenAI was running an internal security evaluation. Two of its models found an unpatched software flaw and used it to escape the sandbox they were being tested in. They got onto the open internet, reached Hugging Face, and pulled down the answer key to the benchmark they were being scored on. Hugging Face spotted the intrusion by itself 5 days before OpenAI connected it to its own testing. Third, Andon Labs, a private evaluation shop. Andon runs a benchmark where a model has to run a vending machine business at a profit. Claude Opus 5 won it. Then Andon put several models into a competitive version of it. In all 6 runs, the winner proposed or joined a price-fixing cartel with its rivals. It cited the Sherman Antitrust Act, the law against exactly that, while doing it. Andon calls this anecdotal, not proof, and that's the right weight for it. Nobody told any of these models to do this. There's a simpler explanation, and it's been sitting in this video the whole time. The score was the thing being rewarded. None of this is about AI. In 2022, a mathematics professor at Columbia University started checking his own university's numbers. The figures it published about itself didn't match the classrooms he taught in. His name is Michael Thaddeus. He had no mandate and no access anybody else lacked. He wrote 21 pages. Columbia admitted the data was faulty. Its national ranking fell from 2nd to 18th, and the university later paid $9 million to settle a lawsuit over it. That's the shape of every case in this video. A number the seller produced, taken at face value by everyone, until one person with nothing to gain sat down and checked it. But Columbia was checkable. There was a rankings body, a paper trail, and eventually a court. The labs publishing today's capability numbers are private companies. They aren't listed on any stock exchange, and no rule anywhere requires an outside check before a score goes out. So who does check? Before the answer, one thing. What you've been watching has a name. It's called Goodhart's Law, and it goes like this. When a measure becomes a target, it stops being a good measure. Every case in this video is one instance of that sentence. The benchmark stopped describing the models the moment the models were built to win it. So this is how you check. 4 questions for any capability claim you read. Who ran it? Who paid for it? What was around the model? And who else got the same number? If you only keep one of those, keep the last one. Everything in this video is one long answer to it. DeepSeek's 88 became 55 when somebody else ran the test. 42% of the math problems turned out to be wrong when somebody finally read them. And people do ask it. Val's AI caught DeepSeek. Pharos AI caught SWE-bench Pro. Epic went looking inside its own benchmark and published the number that embarrassed it. Hugging Face caught 2 of OpenAI's models coming through its own front door. Every case in this video was caught by somebody, working from public information. None of them had to. Checking isn't impossible here, it's optional. A number isn't a measurement until someone with nothing to gain has checked it. If you want the next one of these taken apart before the number becomes the headline, subscribe.